Welcome to Breadboarding. In this video we're going to be looking at breadboards of all types, so solderless breadboards such as these ones, and also the solder breadboards such as the strip board here, and some of these other sort of proto boards, and also the sort of breadboard adapters. So this is the first video in a new series on how to use breadboards and retro digital electronics. I started this channel around August 2022 and it started with the first project here, which was a Motorola 6809 based project called the NanoComp, and this was built out then with a VGA video, a PS2 keyboard, hard disk up here, and also sound and joystick. And after that project completed, then moved on to try and build a breadboard PC. So this breadboard PC was based on the Intel 8088. The version 1 project used original components where possible, so generally chips from the 1980s and in some cases early 90s. And we built two video controllers, a monochrome display adapter and a color graphics adapter, again with a PS2 keyboard and mouse, a floppy disk this time, and an ID hard disk. We managed to get MS-DOS and Windows 1, 2 and 3 running. I rebuilt this starting at the beginning of 2025, and the intention here was to use modern components where possible. So the processor used on this, the Intersil 80C88, was in fact purchased from Mouser and is still available. It's not cheap, it's about 40 odd pounds, $50 odd or so. And the version 2 breadboard PC was trying to address some of the shortcomings of the earlier version, and you'll see here in particular it was actually using strip board bus rails here in particular. So we're using a mixture of both solderless breadboards and breadboard adapters. You can see there's a 100-pin breadboard adapter down here, and also using strip board as well where it makes sense. And most introductions to breadboards cover the origins of the name. And in the first video I produced on the site, there will be links at the top of the screen up here. Put out a couple of photos from some radio websites, and this is showing where circuits were put together, particularly with valves were actually just screwed into bits of wood, very much like breadboards, and generally the connections are soldered together. And in the video that I include the link above there, I showed how to build a multi-vibrator circuit using the sort of cups here. And also I think this is from the Adafruit website where they've got an example of just hammering nails in and again soldering the wires between the various terminals there. Now in the first video I covered one of the patents that I came across. So the picture here shows the breadboard probably in the form that most people would recognise them these days. It was originally granted for this particular design to Ronald Portugal, is applied in 1971 and granted in 1973. Now, one of the commenters who commented on the video fairly recently identified that at the bottom of the document there was actually a reference here for some prior art. And I did actually have a look for this. I couldn't find the 1964 version and the particular page, but I was able to find something that did look somewhat like a plug patch board here, which looked like it was similar to what the initial breadboards were. And I also dug a little bit deeper into old archives of electronics magazines, and the earliest one I've been able to find in the UK in particular was the S-Deck breadboard, which appeared in October 1967 Practical Electronics. And this seems to be one of the first sort of pictures I've been able to find of a breadboard, not in the same format with integrated circuits, because generally integrated circuits probably weren't widely available in 1967. They largely came in the early 70s. Then moving on to the 70s in the US from Byte magazine, then certainly 1975 there were these breadboards appearing in adverts, and also I was familiar with the Euro breadboard, was certainly advertised in UK electronics magazines in the late 70s. So breadboards have been around for quite a long time, but not aware of many projects where they've tried to build such large projects as the ones I've been working on in the last couple of years. Let's take a look at a breadboard and just look at some of the key features of it. This is an example of a busboard prototype systems, BB630, BB830. And in the video that I linked to earlier, there were some links to a number of reviews of different types of breadboards. There's very variable quality in breadboards, and to be honest, if you're wanting to make complex circuits, I would just go straight to the busboard ones and don't try any of the others. They generally won't let you down, and they're generally very high quality, but not too expensive. So you'll see down here we've got power strips along the edges, and all these strips here, then these 5s are actually joined up, and then there's a channel down the middle, and the reason for the channel allows us to actually plug in integrated circuits, which generally these pin spacings here are 1/3 of an inch, and so we can plug an IC or a chip into here, and what we can then see is that for this pin here, all these other holes here are all connected with a strip below the plastic here, and similarly here on this side, then these are all connected, but there's no connection across the 2 pins there. Then all of the power pins down each side of the strip are connected. There are some types of breadboards which don't do this, we'll come to that in a minute, and generally these plus and minus, which we normally use for 5 volts and 0 volts or ground, now they're not actually connected, so quite often what we have to do when wiring up breadboards, we need to wire up the plus power side and the minus power side so that these 2 lots are actually wired together. And then generally these types of chips normally have the ground on the bottom left corner and the 5 volts on the top right, and you can see here the sort of mark at the top here tends to indicate where pin 1 is. The top of the chip is up here. Now I've included a link to Busboard here. I should say that I don't get any sponsorship or any money from Busboard. I've paid for all my own breadboards, so I've just found that these to be the most reliable. If anyone's ever seen any Ben Eater videos where he's sort of built a number of complicated projects, again he recommends using the Busboard ones. If you go to the website, they include quite a lot of information about the different types of prototyping boards and systems that they've got, and the data sheets on this, you'll see that I've actually taken some of the images actually from the data sheet here. And the key thing really here is that they actually test their breadboards for 50,000 insertions, and they're using phosphor bronze plated nickel finish. So a lot of the cheaper breadboards don't use phosphor bronze and this sort of finish, and so they aren't as reliable. And in that particular document, it also shows, this is effectively showing where the physical connections are. You can see that these power strips are connected all the way along, and that there's a break in the middle for all of these. Also note that the numbering here is actually quite neat, that the actual number 1 is actually right on the first row, goes up to about 63 rows here, I think, and that you've got ABC down to J there, just to help if you need instructions for actually which wires to connect and hook up. However, there are a number of the cheaper breadboards have split power rails, so you'll see here that the power rails here actually have a break in the middle, and that in fact if you want to use the breadboard in the way how most people want to use them, then you actually need to include wire links here. Now I'd also say, if you have a look at this particular picture, if you'll notice that the 0 there doesn't line up with any of the holes here, and that the AB down to J there and the A to J don't line up either. So the quality of some of the cheaper breadboards is very variable. Not to say that you can't find some breadboards which might be okay, but there are also some very cheap and nasty breadboards, and that this potentially will waste you a lot of time. Probably fine if you're just putting a couple of LEDs together on one breadboard, but if you're trying to build any complex projects, you're going to run into problems with them. Let's take a look at the breadboards that we've got here. So this is the Busboard prototype system, the main breadboard that you'll likely get. This is known as an 830 point breadboard. So generally the power strips down here have 100 each, and I think this has 630, so 63 rows of 10. So that's what it tends to be called. And in fact, on the Busboard ones, they've actually put busboard.com and BB830. Now, BB830 has been trademarked. You can just see there the BB830 on the right there. So if you've got that on there, then it should be an original Busboard one. Now, when you buy these, you're generally going to buy these ones, the 830s, this size, but invariably what we want to do is to connect them together. And the only problem is if you have lots of breadboards just like this and you join them together, what you'll end up with is sort of this sort of thing where you've got 2 power rails in the middle here. So in fact, what I tend to do is when I'm buying in bulk, which I do buy a lot of breadboards, So this is just some of the breadboards I've got from disassembling the version 1 project, which I included in the previous summary video. So that's only probably about 2/3 of the breadboards that I've got unused there at the moment. And what you can do is you can actually buy these strips. So this is a 630 strip. You can buy these individually or in bulk. I tend to buy these in packs of 10. So Mauser in particular, I buy these from. If you buy 10, then you get a discount. And so what this means is you can actually plug these together. So if you had a load of these and a load of these, and you can plug them all together, then all you really need is a couple of these sort of power strips. So rather than buying lots and lots of those and having lots of these left over, what I tend to do is buy some of those, and a handful of these. That means you can build all these things together without wasting any. Now, another interesting thing is that the busboard also produced these sort of solderable proto boards, and they're actually designed to pretty much match the layout. There's an extra couple of rows of power rails and also things at the top. I think that particular one is the original one they did, called the BR1, I think. And then there was a later version called the SB830, which is very similar, but you'll see there's a slight difference. It's slightly longer, and some of the layout is a little bit different. You compare the two, one is a couple of holes longer. So those are quite handy if you wanted to make something more permanent, or if you're working on very high frequency work, then you might find that you might have to solder some things into a board like this if you're running into stability problems. So this is the strip board or Vero board. So in the UK, Vero board is the name of the company that makes these things. And in general, you're going to get these in, this sort of size, which you can then cut down or snap into this sort of size. This is one of the largest bits I've got. This is what I made my bus rails from. I had a number of people ask me about this. If you contact Vero board directly in the UK, I think this thing is about 8 inches by 15 inches. So it's about 78 strips across, and this is what I've been using for my bus rails for the version 2 project. Then there's also other types of proto boards. So this board here I'm going to be using in another month or so's time. This is a 132 pin PGA holder here, and this is so I can plug an Intel 386 into here. And you'll also see that in some of the other series that I've done already, that if we want to use modern surface mount chips, then they can't easily be plugged in obviously to the breadboard, but these sort of surface mount to DIP adapters, so DIP is dual inline package, then these will allow you to solder the surface mount chip on here, put pins on here, and then plug them into breadboards, and they tend to support different sizes. So this is sort of the 0.8mm pin pitch, and that's the 0.5, so they're really fiddly to do those. And then, as I showed you a little bit earlier, this is a 100 pin surface mount breadboard adapter, so this really does get quite tricky to fit all the wires in there, even when you've got all of the cables and things going in here. So that's a 100 pin on that side, and I think it's a 64 pin on that side. So these are the sort of things that help you to use more modern chips with the solderless breadboards. Now in the PC series, I covered this 8088 project book by Robert Grossblatt. So there's a link there, and there'll be a link in the description below. This is available on archive.org. And the key thing here is it actually takes you through building projects using the Intel 8088. So this will cover a lot of the digital retro-electronic sort of information, certainly if you're not that familiar with it. It doesn't build a fully working PC, it builds some sort of digital clock type thing, which is run by the software. But this is quite an interesting one. There's also a lot of interesting sayings in there. It's quite a quirky book, but it's certainly a good read. I've summarised a number of his laws of life and design. The golden rule being think for yourself. So don't always trust what other people tell you, and particularly don't trust what I tell you. Sometimes you need to think for yourself. I can make mistakes and have made mistakes quite regularly. There's no substitute for a data sheet. It's always worthwhile going back to the data sheets and read them and reread them, because sometimes there's things in there that catch you out. Another key thing, if you can't afford to blow it up, you can't afford to use it. Well, I'd modify that slightly, but when you've got the sort of £40 chip, for example, then you have to be very careful with it, because it is going to be painful if you blow it up. Most of the chips that we're going to be using here are probably less than £10, $10, but some of the things like CPUs and things will be a bit more expensive. Ironically, the legacy ones, the old ones, the ones which are 40 years old, probably are cheaper than the more modern ones. And the one that we're going to be focusing on here is a circuit of 1,000 parts starts with an LED. And we're going to start first of all with our solderless breadboards, actually just with a very simple LED circuit. So LED means light emitting diode. Everyone will be familiar with sort of the red glowing lights and green lights. More recently, blue ones became available, and now also white as well in the last probably 15, 20 years. The key thing about an LED is that if you just plugged it in across a battery, chances are it will glow very brightly and then will probably die. Now LEDs have something called the forward voltage, and when it's in a circuit like this, what we normally need to do is include a resistor in series with the power source so that it limits the amount of current that goes through the LED. But this voltage drop across the LED varies by colour and varies even by the individual LEDs that you buy. So different LEDs will have different ratings. But in general, between 2 volts and 3 volts, the maximum current for an LED is normally between about 15 and 30 milliamps. So if we're looking at about 10 milliamps, then that will be generally give a bright enough thing without actually stressing anything too much. And there's a tool here at RS Online, or Radio Spares as was originally. And this is where the diagram I've borrowed. And you can see here, if we put the 5 volts, which most retro digital electronics like the Intel 8088 use, 2 volts forward voltage, 10 milliamps current, gives us a value of about 300 ohms. So in a lot of circuits, you'll generally see the resistor values here will be a value between 330, 220 ohms. It's possible to make it a bit lower than this if you want it to be brighter. And in some cases, you might see higher values, 560 or even 1K. But in those cases, the LEDs will probably be quite dim. So we're going to look at building that circuit now, and then we'll go on later to add a chip to flash the LED. So let's take a look at the breadboards that we're going to be using. So this is the one we were looking at earlier. This is the BB830. Now, they do a transparent one, and this is quite an interesting one to look at. So we'll perhaps just use this for now rather than the white one. I won't generally use this and the rest, but you can see here that this allows you to see the terminal strips that are actually inside here. And what I'll also do is I have got a digital microscope here. If we just have a look at the digital microscope and have a look at the connectors under the microscope, I think you'll see that there's quite a big difference between that. And I've also got a cheaper breadboard. So this is one I just got off of Amazon. It's about £3 or £4. Switch electronic breadboard, I think. So I'll have a look at that one as well, and we'll see what the difference between the connectors are in each of the pins. Let's look at the microscope. And what you can see here is that the metal parts in the busboard breadboards look to be slightly sort of coppery, so they're phosphor bronze. And you can also see that the shape of them, that they kind of have a slight curve, and they're actually relatively close together. And you can see if we put a thin wire in there, then probably it's going to get a reasonable contact, and the surface is a little bit curved. And when you see these things when they've been pulled out, you can see there's kind of the shape's being pressed quite carefully to make this into quite a good receptacle for wires. And if we now just swap over to look at the cheaper breadboard, and you'll see here that the contacts, they don't look quite as nice. You'll see that they're not really at the edges of the hole there. So when you try and insert a pin, sometimes they won't go in very easily because they'll come straight down on that bit in the middle. And you can see that there's a bit of variation in where the bits of metal are there. So I think you can probably see fairly easily if we had a thin lead here, then you may not get as good a contact because it isn't actually in that sort of curved shape. And there is a sort of a bowl sort of shape in the middle of the pin for the busboard ones, whereas these ones are just flat. So I think you could probably get an idea that these may work fine for a number of insertions, but over a period of time they probably will start to have a poorer contact. I'm not sure these would stand up to many hundreds or thousands of insertions. Let's clear that away. So here's a breadboard. Now the first thing we need to do is to worry about power. Now because we're dealing with retro digital electronics, we're going to be using 5 volts. So most of the early microprocessors, certainly the ones from the late 70s and early 80s, all use 5 volts. Some of the very early ones used more exotic power supplies like -5 volts, -12 volts. But the ones we're going to be dealing with are all going to be using 5 volts. Now there's a number of options for power. In Ben Eater's series of videos, what he basically showed is how to take a standard USB cable, chop the end off it, and actually solder 2 wires. So you have to work out which of the 2 wires that has the plus and minus, or the ground and plus 5 volts. And that will then actually give you something which, if you then just plug that into a standard sort of USB power source, this is an old Apple iPod one, I think. And if you just plug that in there, then that will give you 5 volts. And that's probably good for 0.5 amp to 1 amp. Some of the power adapters can struggle with higher currents, and you really want an older one without any of the modern power delivery stuff. Otherwise, you may struggle to actually get the power out of it with a simple cable like that. But I'm not going to use that for now because I don't really want to sort of advise people to start soldering things quite yet. So we're going to use another option. So this is a little module, and I get this from the supplier bits box that I use for most of the day-to-day bits. The more exotic and difficult to find bits I tend to get from Mauser in the US. But this is actually a 5 volt and 3.5 volt sort of power supply, and it can actually have a sort of an input power jack between, I think, about 7 and 12 volts, or we can just plug in a USB connector into there. Now I tend to use this just with USB. So all we can do, because we've got some pins there, it just plugs straight into the breadboard, and it will actually fit the standard breadboards that we've got here. Now the only thing we do need then is a USB cable, and it's a bit of an odd one in that it's got a USB type A plug on each end. Now that theoretically I think wasn't to the specification, but it's you can buy these cables. And all we're going to do is to plug this into the USB power supply. Now I'll just plug this into the power that I've got at the back of the desk here. Now one thing I did notice is that when you plug this in, then it does tend to wobble about a bit. So I've just made a little thing here out of some 0.1 inch pin headers. So these are sort of fairly standard pin headers you can get, and I use these sometimes in the projects. You just take one of these and just leave a couple of pins in there. That just gives it a little support. So if we then plug this in here, we've now got ourselves 5 volt power supply. We just need to check that the 2 jumpers there are actually switched to 5 volts. If we were doing this with more modern computers, particularly things like the Raspberry Pi and things like that run off 3.3 volts, and this is also able to do 3.3 volts as well. Going to leave it on 5 volts for the moment. Now one of the other things I've done a lot in the projects that I've done is these little voltmeters here are quite handy, and I tend to put these on all of the projects just because sometimes when you've got a lot of breadboards daisy chained together, the power can drop to be quite low on some corners of your project. So now what we can do is, if we just turn on the power to the USB power supply, and there is actually a power switch on here as well. So you can see here, it comes out at just over 5 volts. And what I can do is just test this with a voltmeter. So this is quite a nice voltmeter I got from the EEV blog. It's quite expensive, but you can buy fairly cheap and cheerful voltmeters for probably £5, £10, $10 or $15, that sort of amount. And they'll do the job for most of the sort of things we likely want to do here. So just going to plug the ground into that rail and the 5 volts into that rail. Just verify, is our meter giving us an accurate reading? Yeah, it's pretty accurate. So 5.126 on the main meter here, 5.12 here. So sometimes they might vary by the last digit by a couple of digits either way, but generally that's okay. Now what I have found is when I was daisy chaining lots of breadboards together, In the early days, I was finding I was getting down to about 3.6, 3.7 volts sometimes, and that certainly would cause problems. So we've got some power. So now what we need to do is to look at what we're going to do with the LED. So I've got some modern LEDs. Again, these are just ones that I get from Bitsbox. So I've got a couple of those. They're standard brightness, nothing special. I also got one of these. This is an LED from the early 80s, so probably about 1981, and I thought it's interesting just to compare the brightness of a 45-year-old LED with a modern one. Now what we're also going to need is a resistor. So if you remember the resistor value that we calculated over here, for a red one we probably need about 330 ohms. Now I'm not going to cover the colour coding of resistors yet, I'll leave that to the next video. But I have got a 330 ohm resistor which happens to have orange brown. So just zoom into the breadboard first. Unfortunately, the transparent one's not very easy to see the different colour power rails. So the black is on the right hand side and the red 5 volts is on the left. So this is our resistor, orange brown, and then there's a gold band that shows the tolerance. So that's how we know which way around to read the values. Now we're also going to make up some links. So we need a 4-hole link to tie the cathode of the LED to ground. You can buy kits like this, jump wire kits, where all of these leads are already made up. But I prefer to, I have tried using these in the past, but I prefer to keep with a colour coding, meaning of the wires, which is more related to function rather than length. So I'll show you in the next video how I make up my own cables and wires. So just going to turn this off whilst we hook it all up. Now the most important thing about LEDs, other than making sure that we use them with a resistor, because if we plugged this LED straight into the 5 volts, then it would just burn it out. And I did try this earlier and just plugged in the LED without a resistor and it went dead very quickly. Now I always forget this, but one of the LED leads is generally longer than the other, and it's the anode or the positive, which is normally the longer lead, and the negative or the cathode is a shorter. So I tend to think cathode is negative, so it's smaller. And when you're looking at the symbol here, then the current is actually going from the positive to the negative in the normal sense of how we think about things in electronic circuits. And so the current is actually going in the direction of the arrow. And so the anode is on this side and will normally go to the +5 via a resistor, and this will go to ground generally. So that's what we're going to be doing for our circuit. And also, if you happen to have chopped off the leads for the LED to be the same length, then generally the large terminal within the LED is generally the cathode, and the small one is in fact the anode, if you ever do happen to chop the two leads off to be the same length. So this is going to be a very simple circuit. We're just going to zoom into the section of the board we're going to put this in. So this is the LED. So the short lead is a cathode that goes to ground or 0 volts. So we'll just plug in our tie to 0 volts there. Short lead goes into that strip. Then we're just going to get our resistor, and we just need to plug that in between 5 volts and there, and then we're just going to use a jumper cable to connect the resistor to the anode. Just means that when we want to try some other values later, it's easier to do that. You can see everything. At the moment I haven't got the meter attached to anything, but I'll show you what I'm going to do with that in a minute. Now we're just going to turn on the power, and hopefully, yes, we've got the LED is lighting. If we were to make a mistake and we were to put the LED the wrong way around, then in fact the LED won't actually get damaged by being in the wrong way around. Some components will get damaged by being in the wrong way around. We'll cover that in the next video. But you see there, it won't come on, but we can just turn it around and it should be okay. Now the problem when I'm doing these sort of videos is when you're looking from the side rather than the top, then sometimes you don't always get the pins in the correct hole. Hopefully I've done that okay. So there we go, very simple circuit. So what I'm going to do now is, what I've also got here is my older LED here. So if you see how bright that is, it's fairly bright. Let's try the old LED and see how that behaves. and the leads are a fair bit thicker. Okay, so this is exactly the same resistor, exactly the same power, and in fact you should be able to see there that it is quite a bit duller, and looking at it actually here from above it's noticeably duller. So there's a big difference in the brightness between 45-year-old LEDs and modern LEDs. So what I'm going to do is I'm going to wire up one of the new bright ones, and then I've got a number of different values of resistors which I'm going to put in down here, and then we'll see how the brightness varies with the different resistor values. So just going to tidy up our control LED there and just swap back in one of the new ones. So this is the one we're going to be testing with its tied to ground there. These are the different resistors I've got, so I'll cover the colour coding for these in the next video. We're just going to put them in. I'm not going to bother to trim the leads at this point in time. This is going to allow us to test out the brightness of all these different values. I'm just going to swap the meter over there to measure current. Okay, so I've wired this up. I've sped it up just so we didn't have to hang around watching me doing this. So these are all the different resistor values. So I've got one here with a 330 ohm. That's our control. Got another one here, and all I've done is I've hooked this up as a milliamp meter. So this will tell us how much current is going through these ones at the time. And then all I need to do now is just to wire in the other end of the meter. Okay, so all we need to do now is to put this on all the different resistors. So for the moment I'm putting it on the 330. So when we press this, then hopefully we'll have both of them at light. I think they're both pretty much the same intensity, and if you look on the meter, I'll write in what current we get out of these. So this is 9.32 milliamps. Okay, so now what I'm going to do is to go along the track here. So this first one is 100 ohms. And you'll see, and in fact, the voltage here has dropped a bit because of the current going down here. It's actually dropped a little, and we've got about 27 milliamps. That's probably at the upper end of what these particular LEDs are happy doing. As I said, if I shorted this to 5 volts, then it would blow the LED up. Now we've got 150 ohms, that's 19 milliamps, 220, 13.3. So we've already done 330, so let's do 470. Now we've got 5.65. Then we go down to 1 kilo ohm, 1K, 3.25 milliamps. And then this is 2.2K, 1.49 milliamps. Now, if you actually look at the intensity of the LED here, when I look at it from above, then there's a noticeable difference in the intensity. The camera probably doesn't pick it up quite as well as it does, but you'll see that 2.2K with 1.49 milliamps is not too much different from 330 with 9.32. So it looks like you could probably get away with running modern high brightness LEDs, or these normal brightness, but then modern LEDs with actually quite a bit lower current. And the reason why this might be interesting in the future is certain chips may struggle to drive higher current, certainly 9 or 19 milliamps, and some chips might struggle to do that, but most chips should be able to do 3 milliamps or 5 milliamps fairly easily. So we've managed to do ourselves a LED test rig. We've got some power sorted out, but you can see that depending on the amount of current that we're drawing, then the power may vary. If we just go back down to the highest current one and see that, yeah, it has stabilized at about 5 volts there. So there we have it. So we've got an example of how the different resistor values will control the brightness of the LED. That are really probably a 1K resistor is probably okay, because you can still actually see it sort of reasonably clearly when we have the 1K resistor there. So I'll just show you where I got these things from. The Bits box in the UK is in Birmingham or Solihull in the UK. And the reason why I use Bits box is that if you place the order overnight, then quite often you can actually go and pick up the components from the front of the building, generally by about 11 o'clock the next morning. So I think it's only a 30p sort of order charge, so it's cheaper than having it posted to you, and also you can generally get things within a couple of hours. So this USB to A cable, they have some of these, so about £1.90. And this is one of the breadboard power supply modules. So you can see here we've got the USB input, the power supply, so 6.5 to 12 volt DC input if you've got one of those, and it's only about £1.50. The nice thing about Bitsbox is they generally have quite good value components and things, lots of microcontrollers and things like that, but they don't tend to have an extensive range of logic chips, but for that I tend to buy things from Mouser and some of the other UK based suppliers. Should say I don't get any money, buy all my parts from Bitsbox, so this is just sort of where I get my parts from. And the little voltmeters I showed you as well, they are also available from Bitsbox as well for a couple of pounds. So that's what I was going to do for now. In the next video, what we're going to start looking at is the NE555 timer. This is one of the most common chips on the planet. I think more than 1 billion are made a year. There's probably 30 to 50 billion have been used over the last sort of 55 years or so. So we'll be looking at that in the next video, and that will also introduce us into some of the other components. So things like the resistors, capacitors, how to cut leads and how to make the wires to plug into the breadboard. So that will be in the next video. If you don't want to miss out on future videos, please hit subscribe. And if you found the content interesting, please hit like. It just helps to make it available to more people. Thanks for watching.